Yeah, we can start where, yes, that's a good one, Dave. What we want to do is start on that one, and what he wants to do on that is 8, 9, and 10, because he solved 1 through 7. He did the graph.
Okay. So for 8, how would you come up with an equation for that supply graph?
I don't know.
First of all, I didn't have a chance to check whether that graph was accurate. Let's see. When 1 equals 35, 2 equals 130. So 1 equals 35, 2 equals 130. Okay. If you were to extend that graph all the way over to the y-axis, where would it cross?
Move it down a little bit better so you can see it.
Let's figure out what the slope is.
We're just going to move down the graph a little bit if we can.
Well,
no, okay.
actually,
hold on.
probably the
we
best.
can do it, David. We got it.
Probably the best thing to do here is let's figure out the slope of this supply graph.
And what's the slope?
The slope is going to be the rise over the run. So we can pick any 2 points we want and figure out the rise over the run. If we take the points from the table, then let's go from $1 to $4 on the x-axis. And what happens to the supply? In other words, if we look at this algebraically, we've got supply is clearly linear, right? It's a straight line. If it's a straight line, then it's going to follow the equation y equal mx plus b, where slope is m, b is the y-intercept. Okay? So you almost always need to know slope. So how can I get the slope? What 2 points? If I decide to use 2 points from the table, which is the best thing to do because you can just pull the values directly from the table, as far as supply goes, let's use this point and this point. Okay? So, slope, let's talk about slope first of all, with the supply line. Slope is what? Rise over run, right?
Mm-hmm.
Well, what would the rise be? Between $1 and $4, what's the rise doing?
It's about 95.
It's going from 35 to 320.
Oh, sorry.
So if I subtract those, I get the amount of the rise. What is the run doing in that interval?
That's on supply.
Yes.
So you try to use your numbers with that, like some of the numbers that you were given on the board. Okay, so what's your supply?
The run is going to be the horizontal axis. The change in that value. Well, when you plotted this thing, the first point you plotted was 135, and at some point you got up to 4, and it was up to 320, or 325, 320. Okay, so the run would be from 1 to 4. The rise was from 35 to 320. But the run is from 4 to 1. So the run goes up, the run goes over 3 on a rise of 285. So there's your slope. Okay?
Okay.
So we know this much about the equation. Y equals 285 thirds x plus some b. In other words, that's our slope equation. That's all we know of it at this point in time. That's our supply equation. Excuse me. Okay? Now, we're not done because question 8 says use the graph to find the equation of s as a function of p. Well, p is our x here. So if we can solve for b, we will be done, at least with the supply equation. All right. There's a couple of ways we can solve for b. Notice that if we were looking at the demand equation, which we will in a second, b is the y-intercept. So we can read it off the demand equation. But for the supply equation, the y-intercept looks like it's going to be in negative territory. Now, you can do this a couple of ways, and I'm not positive which way you would do it. You could extend the line all the way so that it crosses the y-axis. You know, Patrick, I'm getting a bad echo. Do you have a speakerphone that we can use?
Yes, I'll call you.
No, I'm gonna have to call you. It only works if I call you.
All right, give me a call. We got a speakerphone waiting.
What's the number I should call, David?
720-620-3388. I
think that'll sound a little bit better. We won't have this echo problem. I will call you right now. In fact, yeah, I'm going to have to turn off the speaker on my GoToMeeting. Hold on a second. I didn't mean to open that. I meant to open this. All right, so I'm going to call 720-620-3388. And before I do, let me turn this to, I don't know that I have to do that. Let me try.
You are the first caller and will be placed on hold until the next caller arrives.
I'm going to go ahead and end this Google call that I just called you on.
You are the first caller and will be placed on hold until the next caller arrives.
Go to meeting. Can you hear me now still? Yeah, how's that? Can you hear me now?
Yeah, we can hear you perfectly.
Okay, I can hear you now. I couldn't hear you very well on the speaker. And I don't seem to have quite as much background noise here, so it's better. Okay, as I was saying, we've got the supply equation, everything except B. B is the y-intercept. Well, notice that if we draw that line all the way over, we could come up with a decent guess as to the y-intercept. Is that what she wants you to do?
She didn't really say, David, but I think that would be inappropriate, but that's an appropriate way to do it.
Only because it says use your graph to find the equation.
Right.
In other words, there's a way to do it algebraically. We'll just pick another point and plug it in and we could solve for B. But it doesn't look to me like that's what she wants you to do. So extend that line all the way over, use some sort of a straight edge, and give me, it looks like maybe minus 80 would be an appropriate
that's where it crosses. Yeah, it looks to me like that would be about right, because it goes goes down. See, right, if you see any face, if you extend
Okay.
it down.
Okay.
Now
So
it extends here.
this is what I come up with when I look at the graph. I've measured the slope. It's 285 divided by 3 times the price minus 80 as an approximation of where that would cross the y-axis if I extended it all the way over. Okay?
Right.
All right. Now let's do a similar thing with demand. Let's go back to the table and let's figure out what slope is for demand. Remember, slope is rise over run. What's going to be the rise in this case? Remember, we're dealing with this group of numbers now. So when we go from 1 to 4, what happens to the rise?
You have $1, you have $5.30 minus, and you have $4 at 140. So we're going to be $5.30 minus the 140. So it's X2, right? See that? Is that correct, David? It would be the $5.30 minus the 140.
The 530 minus 140, yeah. And that's
Yeah,
$390. But notice that it's going down. So you need a negative sign. And
okay.
We're going to divide that by 3, the difference between 4 and 1, which is going up. So that's a positive 3. This gives us a negative 112. And that jives with what we're looking at. We're looking at a negative slope, right? That's
right. Yeah.
So if we came out with a positive slope, we would have done something wrong, because we can look at the thing and tell that that's got to be a negative slope. Okay? And where is the y-intercept? In other words, now we have our demand function, almost. It's minus 130 times the price. And then what is B on the demand?
Wouldn't it be about 660?
Yeah, that's, or, yeah, 650 maybe.
650, 650, yeah, well.
Since she's having you read it off the graph, it's going to at best be an approximation.
Right.
Merely because it's, you can't be really precise reading a value off of a graph. All right, so we came up with our supply and our demand function. Okay. And let's see, what was the supply function? It was, hold on a second, let me go back up, and 285 over 3p minus 80. So the supply function was 285 over 3 times p minus 80. Okay? So there's our two functions. And question 10 says, solve the system of supply and demand equations to find the price and the number of buttons that Esteban should order for supply and demand to be in exact equilibrium. How does this price compare with your answer in 7? Well, I'm assuming that in 7 your answer was the intersection point, right?
Yep, right. You came up with about 320.
Looks more like 240 to me. In other words, well, oh, you meant 320 on the x-axis. Okay.
Yeah.
Well, $3.50 for the price of a button. Okay, I got
Right.
you. And that
Yeah,
produces a demand of 240. Okay. So
240 buttons.
yeah. So if we were going to answer equation 10 based on the graph, it would be, it should be the same answers we got when we did number 7, or when you did number 7.
Right.
Okay? So let's see if it is by solving these two equations. Have you had solving two equations? Okay. Well, How would we do that, Patrick? How would we use these two equations to figure out where demand is exactly equal to supply? That's essentially our problem, is to figure out where demand is equal to supply. Let's set demand equal to supply.
Right. So wouldn't it be that you have the two equations equal each other? Is that right, Ashley?
Yeah, would you have the two equations equal each other?
Yeah, that's exactly right. Only we're going to solve it algebraically this time. We're not going to solve it by looking at the graph at the intersection point. In other words, whenever you have two equations, okay, so for D, we're going to substitute this, minus 130p plus 650. And for S, what are we going to substitute?
The 285 over 3.
P minus 80. Okay, so now our goal is to solve that equation. Well, notice that we only have one variable and one equation. We can solve that.
Right?
Let's do it. What's the first step in solving this, Patrick?
You would want to get rid of the negative 80, right?
Okay. Usually when I look at an equation, the first thing I want to get rid of is any denominator. How can I get rid of the 3 that I see as a denominator?
Yeah, you times it.
Well, times what?
You times the 285 by 3.
Well, actually you're going to multiply the entire left side by 3 and the entire right side by 3.
All right.
Okay? Only because I desperately want to get rid of this fraction. Fractions do nothing but complicate the equations. So I can get rid of it if I multiply every term on the left by 3 and every term on the right by 3. So let's do that. I'm going to multiply it by 3. Multiply it by 3. What do we got on the left now?
Get negative 390.
P.
1950, said you don't have a calculator, but 1950.
It's 1950. Yeah, no, I don't need you to be able to do that. What does 3 times 285 over 3p equal to? This you should be able to do without a calculator. How do I do this, Patrick? How do I do this?
You just
You're going to want to simplify this 3 divided by that 3. Okay? In other words, when I write 3 times that fraction, it's the same thing as saying 3 times 285 divided by 3. And now I can divide the top and the bottom by 3, changing it to a 1, 1. Now I don't need a calculator. That's 285. Okay? So that's why I multiplied both sides of the equation by 3, was so that I could get rid of that fraction. And I did. It's now 285p. But I got to multiply the 3 times that. What's 3 times minus 80?
What do we, hold on.
Minus 240.
Oh, all right.
Okay? Now what? What's the next step?
You can get rid of the 240.
Okay? So what am I going to do?
You add 240 to each side.
Okay? When I add 240, I'm only going to add it to the number because I can't add it to that. So I now have minus 390p plus 2190 equals 285p. What's the next step?
You could get rid of the 285p or the
Well, at this point in an equation, you want to gather everything that's got the variable in it on one side and everything that's got numbers in it on the other. Okay? Well, if I move this to the right side, it will turn it positive, and then I'll have positive numbers in front of everything. So that would be my next step. There's always multiple ways to go on an algebra problem, but I'm going to add 390p to both sides. That leaves me a positive number on the left and 675 on the right. Now what's the final step to solve for p?
divide.
Let me look and what that is equal to on my calculator. We get a p of 3.2. That's pretty close to what you came up with when you used the graph. 3.2.
So $3.20, right?
Yeah, we came up with 324, but understand that we came up with these two equations reading them from a graph, which is not really the best way to come up with them.
Right, they're just approximations.
Yeah, it's going to be not precise. But it
Came out pretty precise, actually.
it does demonstrate the problem, and the problem is when you're trying to solve two equations, you can do it graphically, or you can do it algebraically. And you did it graphically on number 7, and we did it algebraically on number 10. So the number of buttons you should order would not be P, but it would be S when P is equal to 3.2. In other words, we can come up with the number of buttons now by plugging in 3.24 for P.
Oh, really?
That's what we came up with, a P of 3.24. And then multiply that out, and whatever you get should be quite close to the horizontal, the Y measurement of 240. In other words, we're looking at that point right there on the supply, and the supply and the demand are both the same, they're both 240. Only here we would do the math. We would plug in 3.24, our answer for P, come up with an answer there. Here, I guess I can do that pretty quickly.
Yeah, because when he multiplied that 3.24, again, does he multiply that? Does he have to convert that whole number into a fraction to multiply that against 285 over 3?
Okay, I get 227. No, you know, I just did that on my calculator, Dave.
Okay, so
I multiplied 3.24 times 285, divided it all by 3, and then subtracted 80. And I came up with 227, which is pretty close. You got 240 here, but I wouldn't expect to come up any closer than that.
No, I wouldn't either. But the way the question I asked, when he's got that 3.24 times that, what he does is multiplies it times the top, divides it by 3, and then minus 80.
Yes.
And that solves it. Okay, so I just want to make sure he's got that part of the function.
Yes. Yes.
Yeah. That's where the key is.
You know, if you have a moment here, I came across something since our last session. I don't think I've had a chance to tell you about it. Let me know if I have told you about it already, but it's something I've been looking for 5 years. And it is a flashcard program that incorporates positive and negative numbers. And what I have found is this is where everybody has problems.
This is where he's dead in the water, David.
Well, then let's do this. Let's spend a few minutes going through these, and he can notice that this website is aplusmath.com. In fact, let me take a picture of it. I'm going to copy and paste it into the GoToMeeting chat window. Okay? Now, if he clicks on that, it'll open a window on your computer. Go ahead and click on that A plus Math. And then save that as a favorite in your system. Okay? Okay, now come back to my window. Let's just see how much work you need on this. What is 9 minus a minus 2?
Negative 18?
Okay.
Or, oh, sorry.
We're subtracting, we're not multiplying.
Yeah, sorry about that.
It's all right.
It would be 7, right?
11. In other words, we're going to, when we subtract a negative number, it's the same as adding a positive number. So this is the same problem as 9 plus 2. What's this?
Negative 2.
Okay, let me get my tablet out here. Well, I'm glad I brought this up, because there's absolutely no way you can succeed in algebra unless you've got this mastered. When we have a minus 5 and we subtract an 8, a positive 8, this is a subtraction sign. This is a negative sign over on the left. Okay? So I think the best way to do subtraction when you're dealing with positive and negative numbers is to turn all subtraction problems into addition problems. And I do that by changing the subtraction sign to a positive sign and then changing the sign on the number that was being subtracted. If it was a positive 8, I'm going to make it a negative 8 now. Now, what's the answer to that? What's minus 5 plus minus 8? When you add two negative numbers, what do you get?
Negative 13.
Yeah. Okay, let's go fill that in and keep going. This is division. So we have a positive 5 dividing into a minus 20. What do we get?
Would be negative 4, or would it be positive 4?
Negative 4. Negative into a positive is negative. That's why this program is so good, is because it incorporates negative numbers. What's this?
We have one of each.
Would it be positive 10?
Negative 10. In other words, again, we have a negative number dividing into a positive number. So think of it like this. We have a 10 divided by a minus 1. That's negative into positive. Whenever you are dividing or multiplying, negative and positive combine for negative. In other words, if I had a negative 1 times a positive 10, that would be negative 10 also. Okay? So the key is whether you're doing division or addition. Okay, here's an addition problem. What do we do here? Do you hear a background noise?
You know what? It's a TV. Hold on, David. Let me kill it.
I wasn't sure if that was in your background or that was in some pickup of a transmission from somebody. That's a lot better. Thank you.
Maybe that's causing the back.
That's helpful a lot. Okay. So what's negative 8 plus 6, Patrick?
Negative 2.
Negative 2, exactly. Go ahead. You give me the answers as fast as you can come up with them without a calculator.
9. Negative 11? Or, yeah,
No, that's correct.
Yeah.
Didn't hear.
2? 12. 8.
Negative 7. Notice that it has to be negative.
Yeah, there's one negative and there's one positive, and then it's going to be a negative.
Okay.
That's how you said from the
But also notice that you've gotten better already, just with a few minutes practice on this thing. If you were to spend 5 minutes a night doing this as fast as you could, going through these problems that it throws at you randomly, you would be amazed at how much improvement that did to your math. And I'm not exaggerating that. There is no doubt in my mind that if you could get a lot better at this so that you essentially can go through these perfectly, that's going to be huge for you. Absolutely huge. So what is this?
It frees up his freezing point.
Well, it's absolutely vital. You can't do algebra if you don't know how to do these. You just can't do it. You can't depend on the calculator to do algebra. You've got to be, and you don't need to be able to do double digits times double digits. I don't expect him to be able to do that, but he needs to be able to do single digit times single digit and double digit divided by single digit, like this problem.
Exactly.
Okay, what's this?
Negative 7.
Okay. This?
It's the times.
Negative 12.
Okay, let's go over this one.
Oh, that's a negative.
Got a minus 2
Oh.
minus a minus 6. So it's not multiplication, it's subtraction. And remember what I said to do with subtraction? Change it to a plus and change the sign on the thing that was being subtracted. So now what's the answer?
4.
Positive 4, yeah.
It would be positive 4.
Yep.
It would negative 2.
Yep. This one's a little bit difficult. 9 goes into 108 12 times. Is it positive or negative?
Negative. We negative 80. Negative 6.
Yeah, let me give you a trick that you may know already about the nines tables. Nine times 1, 9 times 2. All of the results add to 9. In fact, you can get the result of the nines tables by merely starting with one digit less than that and then making the second digit be whatever it takes to make that add to 9. In other words, 9 times 6 has to be 5 something. What's the something got to be? It's got to be a 4 because that has to add to 9.
That's slick.
Okay? So there's your nines tables right there. You don't even need to memorize the nines tables. But the 8, 7, and 6 tables are tough for most people. That's where everybody struggles, is with these 6, 7, and 8 tables. So work on those a little bit. But you don't need to actually work on them. So all you need to do is spend a little time in this program, and it'll fix you right up. I'm not kidding you. I don't know how much time, but I'll bet you 5 minutes a night would do it. A week from now, you'd be perfect on all of these.
Yeah.
And I'm serious.
That's good advice, David.
I think that's really a significant step. So let's go back to your problems, and I will leave you with this. Did you get a copy of this site here?
Yeah.
Yep.
Okay, let me make sure that's the same. Doesn't change on me. Okay, let me just show you how this works. You can checkbox if you want to do just 1 digit by 1 digit addition. Checkbox that only. Don't checkbox the 2 by 1s. You don't need to know how to do those. Those aren't that significant. It's not that you don't need to know how to do them. You do, but that's not what's causing you to struggle in algebra. What's causing you to struggle are those 4 right there. So when you practice this, checkbox these 4. The top left under subtraction, and the multiplication and division. And you can even put a timer on it if you want. I would leave the timer off when you're playing with this. And that's the way I would look at it, is play with it. It's a game. You can do it on your own. It doesn't matter whether you're right or wrong. You'll see, and eventually you'll be perfect at it. I have no doubts. All right, let's go back to here. So we need to go to a new page. Looks like it.
Yeah, you got that small page. It's how many questions do you have on that pattern? The
This
small
one?
page is 13. Yeah, that's it. And what we need to do is 11, 12, and 13.
Okay.
And here's some graphs back it.
Let's look at 11. Just a rudimentary graph here is all we need. We're going to graph this. Y is greater than minus 2x plus 2. Where are we going to start?
We're going to start with 2x plus 2.
Start by graphing it as an equation. In other words, start by graphing that. How do you graph that? Where's the first point you would start at?
0.
The y, that's B.
Oh, all right. So
Y-intercept. In other words, we have this thing in y-intercept format. So we're going to go to 2, right there. We only need 2 points to graph a straight line. So how do I get my second point? Slope. What is the slope of this thing?
negative 2x or negative
Negative 2. Okay, how do I graph negative 2? Do I go up 2? Do I go up 1 and over 2? Do I go down? What do I do?
You go down 2.
And right or left
Over.
after that?
Could it be either one? Or do you have to
No.
go?
Notice that if I go left, now I got a positive slope. So whichever way you go has to result in the slope that you know you have. Okay? You can either go down and to the right, or you could go up and to the left. Well,
Right.
down 2 and to the right 1. That's the slope of minus 2, and now I can graph it by just drawing a line through those 2 points. Okay? Now, let me go back and erase that line, because in order to graph the inequality, we have to know whether we're going to draw a dotted line or a solid line. A dotted line comes if it's a greater than or less than only. A solid line would come if it's a greater than or equal, or a less than or equal. In other words, the next number 12, the top line, would graph as a solid line. Both of these in number 11 are going to graph as dotted lines. So let me put the first one in there. Now how about the second one? Y is less than minus 2x plus 4. Let's go back to the first one for a moment. I want to graph that. Which side of that dotted line do I have to shade?
You shade the left.
Look to the y-axis. There's the y-axis. It says y has to be greater than that line. So here's a point that's greater. Here's a point that's greater. So it's this part that I would shade. Whoops.
Oh.
Okay, you with me?
Yep.
Now let's graph the other equation, or inequality rather. And remember, we're going to start off graphing it just like we would graph that equation, only we're going to use a dotted line. So where's my first point go?
4.
What's the slope?
It's the slope on the new one.
What's the slope on this new line?
It's -2.
That's the same as the other slope. That makes that line parallel. If two lines have the same slope, then they are parallel to one another. Now, where would I shade this one? In other words, this line is this inequality right there. Do I shade above or below the y-axis?
Below.
Yeah, this area right here. And that area right there is the only area that is in common between my two shadings. In other words, my first shading, which went like this, and my second shading, which went like this, overlaps in that narrow strip. So that narrow strip would represent the solution zone.
And that's where you shade.
Yeah, that's where the two shadings overlap.
And that's the only part that you shade on the solution, though, in your graph.
Yes. In other
Yeah,
words,
so
when you are graphing the solution, it's just this area right here.
Just the road that goes down the center.
Uh-huh.
Yeah, that makes sense.
Now, number 12. Yeah, we got time to do 12. Let's do 12. Twelve's going to solve very similarly. The only difference is one of the equations is going to be a solid line. Excuse me, one of the inequalities will be a solid line, and one of the inequalities will be a dotted line. So let's take the first inequality. How do I graph that? First of all, let's set it up as an equation. Patrick, what's the best way to graph that? If it was in y equal mx plus b format, could you graph it?
Yeah.
Okay, let's put it in that format. What do I have to do to that equation in order to get it into y equals some slope times x plus some y-intercept? About subtract 2x from both sides.
All right.
If I subtract 2x from the left and the right, now the x's cancel. 2x minus 2x is 0, and I'm left with y equals minus 2x minus 4. I switched them around because I wanted it to be in that format because I know how to graph that pretty easily. Okay? How do I graph that?
Well, you'd start at -4.
Okay, what's the slope?
-2.
So how do I find my second point?
You'd go...
Let's go up this time. I'm out of room on the bottom.
So you'd go up 2 over 1.
Which way?
You'd go to the right.
No, that would give me what kind of a slope?
Positive.
Okay, we don't want that. So that's got to be the wrong way. So it's got to be up 2 over left 1. So there's my second point. Okay? Because this is a greater than or equal, I can make that a solid line. Gosh, hold on. It's hard when you're right-handed to draw from the upper left to the right. Okay, that's close enough. Because it's an inequality, not an equation, which side of that do I need to shade?
Would you shade the left side?
Well, we ended up with this. Y is greater than or equal to minus 2x minus 4. Always look to the y-axis. What is y relative to that line? Is it above it or below it?
Above it.
Above it. So pick any point you want out above the line. Well, there's a point. That means we shade this area from there to there. I'm not going to do it quite so heavy this time. Okay? So that's so far is our area from the first equation. Now let's look at the second inequality, which is x minus 2y is less than 4. Well, let's try to turn that into an equation so we can graph it. How do I turn this into y equals mx plus b?
You would add 2y to each side? Or do...
Well, our goal is to isolate the y. How about we move the x to the other side?
Yeah.
So 2y is going to be equal to minus x plus 4. And again, I put the x first because that's where it goes in the standard format. Now, I got to isolate y. So what's the next step?
You would minus 1y?
No? That's a good thought. That's not a bad thought. But that doesn't work because notice that if I subtract a y, I'm going to end up with a y over here. I don't want a y over there. I want to end up with an isolated y and have only x and numbers on the other side. So instead of adding 3y, we could add 3y to that, and we'd be left with y, but then we'd have 3y over there. So I don't want to do that. What's this minus 2 doing right now? Is it multiplying y? Is it dividing y? Is it adding to y? Is it subtracting from y?
It's multiplying y.
Multiplying. So what do we have to do to get rid of it?
Divide.
Always the opposite. Divide by minus 2. I divide that side by minus 2. I got to divide that by minus 2 and that by minus 2. So now we've got y all by itself on the left. What do we have on the right? What is this equal to?
Would be 2x?
No. The 2 is in the denominator. There is a 1 in the numerator. First of all, let's handle the negatives. Negative divided by negative is going to equal positive, right?
Mm-hmm.
Okay, so let's just erase those. When you have x over 2, that's the same thing as 1/2 x. And people have difficulty seeing that. Whenever you're dividing that x by a number, remember that there's a 1 in front of that x. So it's really like a 1/2 coefficient. Okay, how about the plus 4 divided by the negative 2? What's that equal?
2.
No?
Negative 2.
Negative 2.
You've got a positive and a negative.
Okay, so now here becomes our equation. Hold on one moment. Let me back up here. I use this, change it to an equation in order to graph it, but sometimes that's not really the best thing to do. And I'll show you why. If we leave it in an equality and try to solve it, and put it into y is less than mx plus b, that's better. Okay? The reason is that very last step we did where we divided by negative 2, what does that force us to do with the inequality sign?
Flip it?
Yeah. So I can't really solve it as an equation and then pretend that the sign is still this way. I have to solve it as an inequality because in this case I divided by a negative, which means flips the sign, and now I have the rest of it. But that matters because how do you graph that? Where do you start?
-2.
Okay, our other one started where? At -4? Yeah, so this time we're here. What's the slope on this?
1/2.
So how do I graph another point on this line?
You'd go up 1/2.
Good. Over which way? Everybody says over, but you got to say right or left.
Would be right or the left?
Correct. Up 1 to the right 2. That gives us that slope of +1/2. And dotted line or solid?
Would it be solid?
No, that was my mistake. It's dotted. Because it's just greater than. It's not greater than or less equal to. The first one was greater than or equal to. This one is dotted line because it's just greater than. Okay? Which side of that do I want to shade? Above or below?
You'd want to shade below.
Now look at the y-axis and look at the sign of the inequality.
Oh yeah, sorry about that. You'd want to shade
All right. It's always, in other words, if that's greater than, you're above. If it's less than, you're below. So I'm above this line, so any area here. So in other words, if I was going to shade everywhere above that line, there's my shading, and my result is only the area where both are shaded. All of my solutions have to lie in that area. And that's the way you do these inequalities, is you graph them as best you can, whether you turn it into an equation or graph it as an inequality. It's better to graph it as an inequality if you know how to do that. The only reason I graphed them as equations is it's a little more straightforward. But then you run into that problem that we ran into, and so we really have to graph it as an inequality. All right. That was 12. Let's have a quick peek at 13. So, let's solve 13 by graphing each of these, and our answer is going to be the solution set. How do I graph x is less than 4?
You draw a line at 4 and then shade below it.
Is it a vertical or horizontal line?
Vertical.
Okay. Is it dotted or solid?
It's dotted.
Yeah. And which side of that line am I on?
You're going to be shading the left side.
Yeah, because notice now we have to look to the x. We're not looking at the y anymore. We're looking to the x, and it says less than, so I got to be left of that line. So let's shade with horizontal lines the entire area. Okay. Now let's look at the second equation. Y is less than x plus 1. Well, that's in perfect y equal or mx plus b format. Where would I plot that? Where would I begin?
You'd start at 1.
Okay. What's the slope of it?
It's 1.
So I go what?
You go up 1 over 1.
Which way?
Oh, sorry about that.
All right.
You go to the right.
Okay. You know, every student I have says that, and I can only surmise that the teachers must be saying that. They must be up and over, or down and over. I've heard that for 5 years. I really have. And I don't get it, because it's got to be over a certain way. Otherwise you get the slope wrong. Okay, so which way of that line, is it dotted or solid?
Dotted.
Now, which way am I on this?
Hold on.
The y-axis we want to pay attention to.
So it'd be shading below it.
Yep. I'm going to use vertical lines here to cover this whole area. Notice that everywhere that's below that line, I'm going to shade, even up high. Okay? And finally, the third line. Let's graph that. Where does that begin? That's also an mx plus b format.
Begins at 3.
Okay. And what's the slope?
It's -1/2.
So how do I get another point on that?
You'd go down 1/2 to the left.
That would give me a positive slope. Right? In other words,
Yep.
if my other point goes there, that's a positive slope. So that's the way you figure out which way to go, is make sure that it's going to result in the slope that you want. So I'm going to go down 1/2 to the right. Appears to put it at that point there. It's going to be a solid line, right?
Yep.
And which side of that line am I on?
You're going to be shading above it.
Okay, so let's see. We've got horizontal and vertical. Let me use stripes. Slanted stripes. Okay? Now, what area is everything in?
Hold on.
In other words, where do we have vertical, horizontal, and slanted stripes?
In between where all 3 lines intersect.
Yeah, let's outline it. It's right here. So our solution set has to be inside there. In other words, any x value, or the x and y whole numbers, there's probably only a few whole numbers that are inside that solution set. We certainly can't figure them out from my graph, because I don't have a grid on it. But if you had done this on a nice graph with a grid, you'd be able to figure out there's probably only one set of whole numbers that is inside this area right here. And it's got to be dotted on that edge, solid on this edge, dotted on this edge. Which means it cannot be equal to -4. Excuse me, it cannot be equal to 4. It's got to be less than 4. In other words, 3 or 2 seems like the only possibilities on the x if it's got to be a whole number. And then if x was 3, then y could be 3 or 2. But if you go through these answers here, we don't have time now, and unfortunately I have a 5 o'clock to go to, but you could check each of these values and see if they end up in that solid zone or not. And if they do, that's your answer probably. Looks like 3-3 is probably the answer to me.
He did it on a graph and it looks like 3-3.
Yeah. Certainly is not 4-3, because that would violate this one. And since x has to be 3, it's not 3-4 either, because that would make y 4, and that wouldn't satisfy it either. So yeah, it's going to be 3-3 or 2-2, and if you solved it, you got it. All right, Patrick, I will let you go, and we'll talk the next time, and spend some time on that A+ math. You'll like the results, I guarantee it. Treat it like a game. Just make a little game out of it. Do it by yourself. Just practice it. Okay?
All right.
All right. We'll talk to you later, guys.
Thanks, David.
Bye-bye.